Good morning students. Again I came back with one more video, that is simplex method, which is used to find out the solutions in linear programming problem whenever there are more than two decision variables. If there are two decision variables, we have been finding out the solution by using graphical method, but here we have three variables to find out. They have given the linear programming problem. Now we are going to write the standard LPP form in your solution. When the constraints are of less than or equal to, we are going to add a slack variable. Then there are two constraints, that means you are going to add two slack variables, that is plus S1 here and plus S2 here, to make it as an equality constraint. And whatever the slack variables we have been added, for that we are going to give the coefficients as zeros in the objective function. In the initial basic feasible solution, the decision variables are x1, x2 and x3. We are going to make it as 0. Then we are going to get the values of s1 and s2, which will be called as your basic variables, where s1 is equal to 3 and s2 is equal to 2. While we are substituting all these values as zeros, we are going to get the objective function maximum z as 0. Now we are going to form the initial simplex table. What is meant by an initial simplex table? By taking the proforma CB, basic variables XB, X1, X2, X3, S1 and S2. Whatever are there in the standard LPP form, these values that you are going to write in the proforma. Now we are going to take the basic variables as S1 and S2, where S1 is equals to, from the LPP form, S1 is equal to 3 and S2 is equal to 2. And we are going to give the coefficients of this objective function to the Cj values. And like this we are going to give 1, 1, 3, 0, 0. These the values are coefficients of the objective function in the standard LPP form. And S1 and S2, what are the coefficients for this? Zeros. That's why we have written CB values as zeros. And these the values are coefficients from the constraints. Here there are only two constraints, that means we are going to get the I2 matrix for the basic variables. What are the basic variables? S1 and S2. For this it is going to follow I2 matrix. Whenever we are having more than more than two constraints, we are going to take I3 matrix. When it is of 4, it is of I4 matrix. So here we are going to find out the value of z. What is the formula for z? Z is equals to summation CB XB. Summation CB XB means CB means these values, XB means these values. 3 into 0 plus 2 into 0. You got the value of z as 0. And ZJ. In the same way we are going to multiply with the CB values for all these x1, x2, x3 and s1 and s2. Where in the CB those two values are zeros. That means we are going to get the value of all the ZJs as 0. We are going to find out the ZJ minus CJ, where ZJ minus CJ is nothing but 0 minus 1 minus 1, 0 minus 1 minus 1, 0 minus 3 minus 3, 0 minus 0, 0, 0 minus 0, 0. So this is the initial simplex table. After finding out the initial simplex table, we are going to find out the incoming variable. What is meant by an incoming variable? The most negative value in the ZJ minus CJ is the incoming variable. Then one more important point is, if all the Zj minus Cj is less than or equal to 0, the solution is optimum here itself. But we got the negative values over here. That's why there is an incoming variable, where the incoming variable is nothing but x3. After finding out the incoming variable, we have to find out the outgoing variable. How we are going to find out the outgoing variable? The formula is minimum ratio is equals to xb by x3. x3 is the incoming variable. xb is 3, x3 is 1. 3 by 1, how much you will get? 3. 2 by 2, how much you will get? 1. As it is of minimum ratio, we are going to make the minimum value as your outgoing variable. And listen, this is the important point. If you are going to get any negative values or zeros in the minimum ratio, don't consider that. So here the 1 is the minimum value, that is your outgoing variable. See, S2 is the outgoing variable and X3 is the incoming variable. In the place of S2, you are going to get the value of X3. Now, where these the incoming variable and outgoing variable are there, the intersection point will be called as your key element, which I have been given it as star. So this is your key element. Now we are going to use the row operations by making it into the new table. These the values, the incoming variable and outgoing variable intersected at this value. This value must be make it as 1. The key element should be make it as 1, and whatever the values are there in that column, that means in the key column. So this is the key column. In this key column, this the value of 1, you have to make it as 0 by using the row operations. Now we are going to take the next simplex table, that is the first simplex table. What is meant by first simplex table? After writing the outgoing variable as S2, we are going to write the variable value as x3. In the place of S2, we are going to write x3. x3 coefficient is how much, ma? That is Cj, 3. That you are going to write here. And S1 coefficient is 0 only. Now, from the values of xb to S2, all these variables have been changing by using the row operation. See, in the key element, you have 2. How you can make it as 1? By dividing the whole row by 2. Okay, so here 2 by 2, 1. 2 by 2, 1. 1 by 2, 1 by 2. 2 by 2, 1. 0 by 2, 0. And 1 by 2, 1 by 2. That's why you got a new row for the first simplex table. And I have given you the row operations here, that is R2 dash is replaced by R2 by 2. So here this is the new row, or that is named it as R1 dash, and this is new row that is named as R2 dash. So R2 dash is replaced by R2 by 2. That is what you have given the row operation here. Now what is the row operation for the first one? First row, R1 dash. R1 dash is replaced by R1 minus R2 dash. See, why we are doing like that? We have to use the new row. So here it is the old value 1. That means here in the place key element we have already 1. If you are going to do that 1 minus 1, you are going to get 0. That's why we are going to use the row operation that. So I am going to write here the clear explanation for that. R1 minus R2 dash, you are going to get R1 dash, where R1 is nothing but what you have 3, 3, 2, 1 1 0. See, 3 3 2 1 1 0. What is the value of R2 dash? That is the new row. 1 1 1 by 2 1 0 1 by 2. 1 1 1 by 2 1 0 1 by 2. What we have to do? We have to subtract these two. 3 minus 1 2, 3 minus 1 2, 2 minus 1 by 2 3 by 2, 1 minus 1 0, 1 minus 0 1, 0 minus 1 by 2 minus 1 by 2. This whole new row values you are going to write in this place. From xb 2 to 3 by 2 0 1 minus 1 by 2. Now we are going to find the value of z. What is the formula for z? Z is nothing but summation cb xb. See, 2 into 0 plus 1 into 3. 3. Now we are going to find out the zz values. That is, see here it is 0. That means no need to multiply this row. Now we are going to find out the value of zz. That is 1 into 3, that is 3. 1 by 2 into 3, that is 3 by 2. 1 into 3, that is 3. 0 into 3, 0. 1 by 2 into 3, 3 by 2. We have to find out the zj values. Zj minus cj. Zj minus cj means 3 minus 1. 2. 3 by 2 minus 1. 1 by 2. 3 minus 3. 0. 0 minus 0. 0. 3 by 2 minus 0 plus 3 by 2. See, since all the zj minus cj values have been positive, the solution is optimum here. And what is the decision variable values you are going to get from the last table? That is, x3 is equal to 1. You don't have the values of x1 and x2 in the simplex table where you got the optimum solution. So x3 is equal to 1. x1 is not there here, that is 0, and x2 is also 0. In this problem we have the decision variables, those are 3, x1, x2 and x3. So x1 is not there here and x2 is not there, but x3 is the value 1. Now we are going to check this by using the given objective function. What is a given objective function? Maximum z is equal to x1 plus x2 plus 3x3, where x1 is equal to 0, I already told you, x2 is equal to 0 and x3 is equal to 1. By substituting these three values in the objective function, you are going to get the maximum value of z, where maximum z is equals to 0 plus 0 plus 0 plus 3 into 1, you got the value of 3. Maximum z is equal to 3. That is what you got in the simplex table, that the value of z is equal to 3. If these two values have been equal, your solution is correct. Hope you understood this video. Thank you.